So, have you ever wondered how a self-driving car actually sees the world? Or how a VR headset can map your room, in real time? Well, the answer is all about technology that can see in 3D. Today, we're going to dive into a really groundbreaking AI called Streamer 3, and it's totally changing how machines perceive our world, one single video frame at a time. Just take a look at this. This entire super detailed 3D space was generated from nothing more than a simple stream of 2D images. Yeah, like frames from a movie. This wasn't built by some artist over weeks and weeks. Nope, it was perceived and reconstructed totally on the fly by an AI. And this gets right to the heart of a huge, long-standing goal in artificial intelligence and computer vision. You could call it the dream of real-time 3D perception. And let's be clear, this is not just about making cool graphics for video games. The applications here are absolutely critical. I mean, think about autonomous cars that have to understand the exact geometry of the road and everything on it. Or virtual reality that actually feels truly immersive because it understands your space. It's essential for any robot that needs to navigate and interact with our messy, complex world. But, achieving this dream, it's been incredibly difficult. So let's take a look at the central roadblock, the big problem that has been holding this technology back for years. So here's the crucial point. Making a 3D model from a bunch of photos you took on vacation, that's one thing. But for a self-driving car or a robot, the world isn't a static collection of photos. It's a continuous, never-ending video stream. The AI has to build its understanding of the world as it goes, frame by frame, without ever getting to see the whole video in advance. And that's the core challenge right there. The old methods, they were just too slow, way too computationally expensive. Why? Because they needed to see every single image at once in this big process called global optimization. That just doesn't work for long videos. So the new challenge, the new goal, required a totally different way of thinking. A system that's fast, that processes frame by frame, and that can handle a potentially endless video stream without breaking a sweat. So, how in the world did the researchers behind Streamer 3 solve this? Well, the breakthrough came from a completely different area of AI, one you've probably heard a lot about, the language models that power tools like ChatGPT. This led them to a really simple but incredibly powerful idea. We know language models can read a book, right? One word at a time, in order. So they asked, what if an AI could learn to read a video in the exact same way? The key technical concept that makes this possible is called causal attention. And don't let the name intimidate you. It's actually a super intuitive idea. When you read a sentence, you process it word by word, in order, from left to right. Causal attention forces an AI to do the exact same thing, to only use information it's already seen in the past to understand what's happening right now. And this right here, this is the big aha moment. Stream3R takes that exact same one word at a time logic and applies it to computer vision. It processes a video one frame at a time, using its memory of all the past frames to understand the brand new one. Okay, so we've got the big idea. But how does this frame-by-frame logic actually work? What's happening under the hood to build a complete, coherent 3D world? Here's a look at the architecture. As each new video frame comes in, the model processes it, and this is the critical part. It caches the most essential information into a kind of memory bank. So for the next frame, it's not just looking at a new, isolated image, it's also paying attention to its memory of everything it's seen before. That's how it builds such a stable and consistent model over time. The whole process is actually beautifully simple when you break it down. First, an encoder turns each video frame into digital bits of data, called tokens. Then, a causal decoder analyzes these new tokens. Next, it uses a memory system, called a KV cache, to recall important details from all the previous frames it's seen. And finally, using both the new frame and its memory, it predicts the 3D geometry. And this entire loop just repeats, over and over for every single frame. All right, so the theory sounds amazing, right? But the real question is always, how does it perform out in the wild against other state-of-the-art methods? Well, the results are pretty striking. In this really challenging video with people moving around, you can see how the older methods just struggle. They produce these fragmented, kind of distorted results. But STREAM3R's reconstruction on the right, it's coherent, it's complete. It actually understands the scene as a single, consistent space, even with all that movement. And the researchers themselves, they summarize it perfectly in their paper with this quote. Basically, what they're saying is, it works directly from the video feed in real time without needing any of those extra time-consuming steps afterwards to clean things up. It's just efficient by its very design. So, just how much of a difference does this new design make in terms of raw speed? Get this, it's a massive 40% faster than its main competitor, a model called CUT3R. And crucially, this isn't some trade-off where you sacrifice quality for speed. No, it's also more accurate. And that, my friends, is the holy grail, getting better performance in less time. And you don't have to take my word for it. The hard data tells the whole story. In this standard benchmark test, a lower error score is better. So you can see the older methods are hovering in that 0.6 to 0.4 range. And then there's STREAM3R, coming in with an error score of just 0.264. That is a massive leap forward in accuracy. Okay, so let's zoom out for a second. What does a breakthrough like this really mean for the future of AI? At the end of the day, Streamer is so much more than just a better algorithm. It's a new way of thinking. It proves that the fundamental ideas behind how an AI understands language can be used to teach it how to see. It's bridging this huge gap between two of the most important fields in AI. And this is what really matters. This kind of work is what paves the way for the next generation of truly intelligent systems. AIs that can finally perceive, understand, and interact with the world in real time. It moves us so much closer to that dream of truly autonomous machines. Which leaves us with one final, pretty fascinating question to think about. If AI can learn vision from language, what's the next big idea it's going to learn from itself?